Alright guys, my name's Mike again with A.O. Reed. Today's our last day of training. Today we're going to be covering dedicated outside air units, which is dedicated outside air handler units. The 3 fan coils in the building. 1 is an electric room, 2 are IDF rooms, and we're also going to talk about the exhaust fans up on the roof, okay? We're going to start off with this air handler behind us. Starting on this end right here, this big plenum box right here is going to be your outside air intake. Up inside, we have moisture eliminator filters, okay? It's an aluminum screen, little crisscrosses with a little bit of mesh. So any bit of moisture that's in the air is going to hit that screen. It's going to attach itself to the screen and drip down on the ground outside the unit on the roof, so we don't saturate filters on the inside of the unit, so we don't get moisture inside the unit, okay? You're going to want to clean those. It's going to be dependent upon the weather. Obviously, during times where you could have, you guys get marine layers up here by chance? We're too far inland for that, maybe?
The fog and all moisture.
Yeah, fog and all that kind of stuff. Not too much.
Once in a while,
Okay, so that shouldn't be as big of an issue. We really shouldn't suck up too much rainwater underneath this thing. So those filters should stay semi-clean, right? I mean, you won't have the moisture issue dripping off them. They still can get dirty. Okay, they are a filter. So you'll want to clean those. Since that is the first filter, I would definitely inspect it monthly, but clean as needed. You'll be able to see when they start getting dirty, okay? After that set of filters, we go inside the unit, into the filter compartment. So we have 6 outside air canisters that are drawing the air in from the outside. On each one of the inlet cones, there's flow sensing devices. The flow sensor devices report back to, there's a control board up on the middle.
So the outside air is controlled also?
Well, controlled, it's more just red. It's reading the CFM, okay? And it was set by the balance guys.
Yeah.
So this box right here is holding the computer board that's taking the data from each one of these ports and then adding up that CFM, giving a total right here, and the BMS guys are picking up that point, okay?
Then they open according to the need?
They'll modulate this damper depending upon the outside air economizer, or no, this actually should stay open all the time. This is 100% outside air unit, okay?
This is 100%
There's
outside
no
air.
return on this, nope.
And this is for the dining hall?
This is for the dining hall, half of the hall.
Okay.
There's 1 unit over here and 1 unit on the other side of the
This takes
roof.
care of half of it.
Half of the building, yep.
Okay, so we only got 1 zone or an average
Well,
average.
1 big zone for the air handler, but there's multiple mini zones with VAVs downstairs. Okay, so then
Yes. Okay.
from this air handler.
Right.
And then there'll be a bunch of reheats downstairs
Okay.
that will reheat certain zones. So when you say
Right
zones,
here-
we just want to make sure
here
we're on
you
the
got,
same. We have hot and cold piping.
hot and cold.
In case the temperature ever drops out really low out here, we always want to be delivering a certain supply air temperature.
Right.
So if it's too low, we can use the hot water to boost it back up. I would say about 98% of the time we're going to be cooling the air, right? It's pretty much warm out here all the time, okay? The control guys will open this damper right here. They're all linkage together, okay? All this rod right here, there's linkages that tie all these together. I would inspect those quarterly. If the unit's not running, they'll be closed. You just want to make sure there's no binding. All the lips here should be touching when they're closed. Okay?
How big is the filter?
So we have multiple filters here. We have 1, 2, 3, 4, 5, 6. I believe they're 12 by 24s.
That's it? Let me see that. There's a whole bunch of them. Somebody had me wrong. Where'd it go? Can you pull out the filter in the back? The canister?
Yep.
Is there charcoal?
So these are cartridge filters. So right here we got a MERV 8 filter, 2-inch MERV 8 filter. So what we can do too is look at the door. It's gonna be a 12 by 24 by 2 here, okay? And then a 12 by 24 by 4. MERV 8 is 2-inch, MERV 13 is the 4-inch filter. You can install box filters on the MERV 13s or cartridge. Right now these are set up for cartridge. If you needed a box filter instead of the cartridge, you can just remove this trap.
Let me see this. Can I open it?
Sure.
So it's just.
So that's a MERV 13.
What's open or?
It's a thicker, it's a lower micron filter.
Right.
Okay.
That's a big
This is a cartridge style.
So can you wash them or just replace?
No, these are non-washable filters. They'll need to be replaced.
They're expensive.
And then what you can do is follow the health and services recommendations on filter changes, or as needed. Okay. We'll want to reference the documentation with the filters as far as the maximum filter drop across the filter. Every manufacturer is different, so we need to use that information to go by for the maximum pressure drop across the filter. Okay, it just depends on different manufacturers and the different style of filters. But we have a MERV 8 2-inch filter here, MERV 13 4-inch filter here. Cartridge style right now, you can remove this panel and put a box filter in. The filter sizes are on my startup sheets and on the front of the unit. On the front of the unit, it's just missing the last digits. The top filters would be a 2-inch, the bottoms would be the 4-inch filters. Okay. Controls is monitoring the pressure drop across the filters, but it's the whole rack. When you do your inspections in here, if there is a lot of debris, you'll want to clear the debris out of the compartments. Any questions on the filters, outside air openings?
Don't have to grease anything here.
No greasing here. It appears the unit's off right now too, so. Next compartment down. It's going to be the coils and the inlet to the fan.
You got multiple fans.
Yeah, there's going to be 2 fans in this unit right here. So this is a fan wall application, a 2-wall fan wall. Okay. In a fan wall application, we can run the motors faster than 60 hertz. On the pumps, we stop at 60 hertz. On fan walls only in air handling units, you could run the motors over 60 hertz with the VFDs, and I'll go over that when we talk about that compartment, okay? So this will be how you get to your cooling coil, the drain pan. There's an upper drain pan that drains down into the lower drain pan. There's 2 drain outlets on either side of the air handler that will funnel the upper drain pan down to the bottom drain pan. Make sure the hoses stay on the unit. If they don't, as the water can drip down, it can get sprayed outside of the drain pan and cause a mess. Okay? So we want those drain hoses to remain on the upper pan to the lower pan. Questions on this compartment? This is also the inlet to the fan too. There are no inlet dampers right now. So if you lose one fan motor, potentially you could lose airflow throughout the fan. Does that make sense? It'll short cycle. There's no dampers on this unit that prevent like if you lost it, backflow. If you lost one fan, the other one will spin backwards and you'll lose. So if you lose static down in the building or lose cooling, that'd be one thing to see if make sure both fans are running at the same time.
So both fans have to be running.
Both fans have to be running. I just don't have leverage down here. We'll save this door right here. This is going to be the electrical VFD compartment. This is the controls box right here. And then we have the outlet right here. Be careful going in this door right here. This is a downshot air handling unit. So our air is coming across the unit and then it gets pushed down. So there is a fall hazard here. Please use caution getting inside this door.
Is it
Okay?
one duct?
I'm sorry?
Oh, it's-
Yeah, there's one large duct. Large duct plenum. We have a supply air temperature drape back and forth across that opening to get the supply air temperature.
Okay.
Here. So we do have high pressure resets. The high pressure will be on this discharge side right here. There's a wire switch in here with a white push button.
Oh, okay.
It's a manual reset.
Oh, okay.
There are no fire smoke dampers in this building. So
Or you detectors or dampers?
dampers.
Okay.
So normally that's why you would trip one of these on a high static, right? If you close that damper. I guess if all the boxes went to minimum cooling and the unit tried to ram both fans at full speed, we could trip that. But just know there is a high pressure reset here. We'll double check when you guys do your control checkouts. I don't think there's a low pressure since it's 100% outside air. Just high pressure switch.
So
If you have ductwork on the inlet
so
to
the
the
static
unit,
is controlled.
the static is controlled. I'm just saying this is here
I know what you mean.
is a high pressure cutout. I don't believe we have a low pressure cutout because it's 100% outside air. But there could be since there's dampers. We need to work with Doug and controls and verify that. Or we could open one of the doors and look again. Okay? So that's the compartments of the air handling unit. Up here we do have electrical outlet and then a toggle switch. The toggle switch will be for lights. In this panel behind us right here, there's a little transformer that takes 120 volts and makes 24 volts. The lights inside this unit are run off of 24 volts AC. Okay, so I think there was like 3 lights or so. They should be in each compartment. But there's a plug that you can unplug the light and move the light. If you need multiple lights in one compartment, you can do that. The on and off switch is out here. Then we'll go into the controller, the electrical compartment. So like I mentioned before, we do have 2 fans. This is a double fan wall air handling unit. So we have 2 VFDs. VFD 1, VFD 2. We are in auto, which is good. So for some reason, the controls is not running this unit right now. Like I mentioned before in training, they're still finalizing the integration into this building. Okay, so we do want to leave them in auto mode right here. But they could also not be running because of that high pressure switch. I checked the switch wasn't tripped. What we'd also have to do too is we have these wires, black and reds, coming up into the unit. These are your fire shutdown wires. That's another reason the unit cannot be working. So an easy way to check this would be just press hand. As the unit tries to turn on, it's not going to be one of those external safeties. So right now it tried to turn on, and it looks like it should be, it's starting to ramp right now. So 3 hertz, 4, 5, 6. So we know it's not a safety switch circuit that's keeping this unit off. It's probably going to be the controls guy. Okay. Again, they're finishing their integration into all the units. I press off to turn it back off. It's going to ramp down. But again, we want to keep these in auto. Was I able to talk about the Danfoss VFDs yesterday? I wasn't able to do that, right? Okay. So these are 2 Danfoss. They're called TR150s. That's a specific Danfoss drive for a train air handling unit. But the interface is the same. Okay. So here we have a menu button. We have a back button, the up, down, okay, and a move to the right screen. There's kind of a glare up here. Right now we see an arrow over status. So if we use the down and up arrows, we're gonna scroll through the different options that are available. I press down, now we see horsepower. The used horsepower right now is 0 because the unit's off, okay? But if it was running, it would give you a horsepower reading of what the motor is drawing from the VFD. That can change depending the speed on of the fan, okay? I don't see a reference on this one. It's at 0. This would be a speed signal. Amperage reading, we're at 0 because the unit's off, and then a Hertz horsepower reading. So we're at 0 again because it's off. That's the status menu. If you press menu, you'll go to a quick menu. There's a wizard, a setup wizard. We shouldn't need to make any changes there. We're not using a closed loop setup. This is a quick menu to get into the motor setup. When you get a replacement motor, you need to verify all the settings are the same. So you program volts, amps, RPM, verify the horsepower and the voltage of all those. Make sure you check all of them. Make sure you've ordered the right replacement drive. If it's a 460 drive, it needs to be, the power coming in needs to be 460, okay? It's important. Another super important thing on these train air handling units, these are special motors. These aren't off-the-shelf motors, okay? If a motor fails in this unit, you have to use this part number right here on the outside of the container, okay? Or when you call the train, make sure you get the model and serial number, but you need to make sure it's this part number right here, okay? These motors can be run over the horsepower rating that's stamped on the motor itself, okay? So it's important too. I told the guys this morning in the other units, if you have an issue and you have to call like Danfoss tech support or something like that, be careful taking their advice on motor data programming. These units, again, if you ask for their support, they're going to tell you to program it for the motor horsepower and amperage and the FLA and all that, but it needs to be programmed for this up here. The maximum applied horsepower, which would be 14, and then the motor FLA right here, which would be 17.2 each. That's taking into consideration the higher horsepower of these specific style motors, okay? We're at motor setup. Changes made. If you click that one right there, you can see the parameters that have ever been changed. I've also recorded change parameters on our startup sheets. Those will be turned over for you guys. This keypad has the same feature, a similar feature as the ABBs as far as uploading parameters into the keypad. Once we get through all this, I'll show you how to do that. And we're back to the beginning TR150 wizard. And that's all under this quick menu right here feature, okay? So if we press menu one more time, we go to the main menu. That's where all the parameters are listed now. You can access every parameter here. So 0 is going to be operation and display. So if we press OK, we get into 0-0 basic settings. That's like your language, your country, all that kind of stuff. It's already been set up. If you're replacing a drive, it's something you might want to look into. 0-1 is setup operations. We don't need that. 03 is LCP custom readout. You can change the displays here. On these ones, I've never really needed to do anything like that. And then it says LCP keypad. You can lock the keypad so nobody can make adjustments to it. And then copy save, this is the important one, 0-5. Okay, so when you make a change and you want to upload that information into the keypad, remember uploading is taking it into the keypad out of the drive. When you download it, it takes it from the keypad, puts it back in the drive. Okay, so when you have the drive failure, you'll want to download a full set. So what we do is, the drive has to be off to do this. So we're in off mode. We do copy save. 0-50 is the LCP copy. Right now it says 0, no copy. We press OK. It lights up with a black arrow. And we press up. And it says all to LCP. So all to the liquid crystal panel. Okay. Press OK. And there's a line that goes across. So it's uploading all that information in the keypad. Okay. Once we've done that, the only time you need to do that is if you actually make a change to the drive. We shouldn't need to do that. The most important part would be, now that it's done, is if you click on that, on the 0-50 LCP copy, you press all from LCP to download it into the new drive, okay? If you guys are gonna be doing that part. So So now to go back, I can go back to the main menu. I press back, 0-5, and we'll get out of the zeros. So now we're back to the 0. Then there's load and motor. Operation and display gives you pretty much all the parameters that are in the status, okay? It's pretty much what you're looking at in the status, maybe a couple extra features. Load and motor is where motor data is 1-2. That's where you're going to enter the data of the motors. Remember, this one is different because we're using the front panel information. We have horsepower, we have the voltage, where the motor frequency is still 60 hertz. It's still a 60 hertz motor, even though we're operating above 60 hertz. I'll get into that in a second. So it's the hertz range of the motor itself is what we're looking at right now. Motor current, we use the current data that's on this name tag, not on the motor in this specific instance, okay? Motor RPM, you want that to match the motor RPM. That way the drive can pull the RPMs out of the unit. That's all we need for that, for motor data. Brakes, you can change the features of how the when the motor comes to a stop, that it won't freewheel. If it isn't a stop, that's not this application. Reference and ramps, that's how you would fine-tune the BMS guy's signal coming into the unit. So I've already worked with Doug. We've already verified that his 0-volt signal turns the unit off, and then as he starts increasing his 0 to 10 volt signal, it starts proportionally changing that output, and they're scaled properly. So it's 60, 10 volts at 60, or it's the full hertz range, right? Again, I mentioned this is above 60 hertz. We'll get into that in a second. We want to make sure all that the reference and the max hertz match each other. So limits, motor limits 4-1, that's what I was talking about. Right now we have motor speed low limit. So this fan, we don't want it to spin lower than 20 hertz when it's turned on. Okay, anything lower than that, it can ruin the motor, and it can also cavitate the fan. Okay, so 20 hertz is the minimum. 73 hertz is the maximum we can spin this motor. Okay, to get us the proper CFM at like a full load cooling situation. Okay, every box is wide open max cooling. Okay, 73 hertz. Analog input we have set up for a 0 to 10 volt signal. We're not using any digital inputs into the drive. Actually we are. We're using 5-10 is terminal 18. That's your start. So the BMS guys are using that digital input for start. And then 5-12 is terminal. Inside here, there's a terminal. On this terminal board here. So 27 is going to be the third from the left. So this input right here, 18, is going to be your start. So when it sees 24 volts on this input, it will turn on the drive to minimum speed. If we lose voltage to 27, because we're on coast inverse, then it will ramp the fan down. That's your safety interlocks. Okay, so your fire shut down. If we don't get voltage back into that, it will shut the unit back off. Okay. Voltage comes out of 12 right here. It's 24 volts DC. Can you guys hear me? 24 volts DC. We're looking for that voltage here to start the unit. If we lose it, and we're looking for it to start the unit here. If we lose it on 27, it will come to a coast and stop. Okay. You got output here to the motor. You got input down here into the drive from the fuse block right here. Okay, so it goes in the main disconnect here at the top, goes out through this load block, and then it splits there into each input fuses to each drive. None of the connections from the field were made up here in this, except for the communication wire, I believe. Everything else is made down on this terminal block. can start checking any kind of troubleshooting you need to do. You can start doing it down here. And if you have the voltage here, then you'd want to come up to this panel and verify it here. Or you can start here first. It's up to you guys. I'll put this back on. Any questions with under here? The brown, orange, yellow, that is high voltage going out to the motor. We're not running the unit right now. There's no power coming out of the drive. But it is 480, okay? Common options, these units are set up for Modbus. That's the communication that Sunbelt is using out here. So the units are set up for Modbus and have an address number associated with them. On each one of the main controllers downstairs, it needs a unique address, so be cognizant of that. Each one of these units will have a different address. This will be a junction box for the 120 volts that feeds the lighting panel. Again, the most important part with these drives when you're doing your inspections are that we're in auto, okay? That will allow the BMS guys to turn on the unit and then ramp it accordingly depending on the static pressure in the ductwork, okay? Hand obviously will turn on the unit. In hand mode, at first it'll turn to the minimum speed. So when I press hand, we get a black bar across here. If we press over, now the cursor is on one digit at a time. So right now, the last time it was run, it was at 30 hertz. It's going back to 30 hertz right now. So I can change that by moving this cursor over with the arrow. It's highlighted on the 3. If I press down, it's going to go down by 10s. I'm in the 10s digit, okay? So if for some reason, like I said, if auto's not working and you can't get that thing to turn on, but you got to provide cooling, you can turn this in hand. I would definitely not recommend ramping it past like probably 45 hertz or so, because we don't know what boxes are going to do downstairs, okay? But at least that way we're blowing some air through in the building while we're troubleshooting why auto's not working, okay? And then, like I said too, make sure you use both at the same time. Right now it's just a demonstration, because right now the air is kind of going to go around in circles in the unit, okay? Because the other fan's not spinning.
So what is the static that's maintaining the duct?
That was set up during the balance process. Off the top of my head, I don't know it, but it's going to be in the front. It's going to be in the computer. And if for some reason we ever lose that information, it'll be on the balance report that gets turned over to you guys. So what they do is they get all the VABs on this air handler wide open at their proper CFM values, and then they run the unit. Sometimes they run it in hand, and they see what they leave it in static pressure control, and they see what static the unit needs to run at with all those boxes open in their proper CFM. They write that number down.
Give out the proper CFM in each box.
Yeah, each box is at, because they've already calibrated each box. They know at full cooling that box is making the right amount of air. So then they see what static pressure is in the duct that they need to control to, and then they set that as their set point. Okay. You can move the arrow over one more and go up by single digits, 21, 22, 23 as I press the up arrow, okay? Again, we want to make sure we're in auto mode. In auto mode, we don't have a signal, it's trying to turn back off. You guys have any questions on the VFDs or any of the controls inside this unit? You get what it does? We want both in auto. We want both of the speed signals to match. So I like, where'd it go? So they're both on hertz and horsepower. That way you can compare the numbers together, okay? If you have an alarm condition, you'll have a red light down here. If it's a warning, it'll be an amberish light right here. If you see that and you see a fault code, we got to refer back to the book for the proper alarm or warning, okay? A warning won't necessarily shut off the unit. It's just saying, hey, we're getting in a condition that's, that someone needs to look at, okay? Alarm will shut off the unit and it won't work, okay? That specific drive won't work. If you're getting an alarm on one and not the other unit can still try to operate, But again, we're going to be short cycling air around the unit, right? Because one's running and one's not. Any questions on this one? Okay, we'll move into exhaust fans. If the unit is powered, you have to use a screwdriver to get the door closed. Okay, that, and then make sure you latch the door. Okay, we'll go down the roof here. We'll start at the end. We'll work our way back, and then we'll go to the other roof, and then in the building. Still going? Okay.
What was the word for this for the evaporator?
I'm sorry?
The whole name for that unit.
The name of that unit is an air handling unit.
It's not the evaporator.
It's not what?
It's not the evaporator.
No, there's no evaporator. That's like for a refrigeration circuit. Okay. That just has a chilled water coil in it. Okay, we're just using cold water, passing it through the coil, blowing air across that, creating the cold air for the space. All right, guys, we're still up on building D roof. We are on the water heater side of the building that we talked about before in the training. We have exhaust fan 2D right here. That's going to feed the dining area. It's going to serve the Mexican grill. Okay, that'll be downstairs below us. These fans are all controlled. Or this fan right here is controlled off the Ansel system as well. There could be a push button, or it might just be off temperature. The Ansel system was provided by the electricians. Same with the starter right here. The only device to turn on a fan that the mechanical contractor AO Reed or ABET contracting provided was the VFD that we spoke about yesterday that's on exhaust fan 1D. So if there's an issue in this fan, if the fan won't turn on, we need to do troubleshooting inside the unit. If you're getting 480 volts on the output of the contactor and the fan's not running, it would be a service call to the mechanical. Anything, if you're not getting the 480 coming out of the unit, it'll be a service call to the electricians. Okay, it's their starting device. Since it's an Ansel system, the auto switch doesn't really do anything or off. The starter's wired from the 24 volt transformer straight to the contactor. Because if the Ansel system's running this, it doesn't matter what the switch is, we need it to turn on no matter what, okay? But the unit will turn on in hand up here, as of now, okay? So if there was if the Ansel system wasn't turning it on and one of you guys needed to run the fan, you can come up here in hand and put it in hand, but it'll run forever. Nothing will then shut it back off, not even the Ansel system, okay? It'll be stuck in hand mode, and then the light will turn red and turn on. These are belt-driven units. Now that we're going to be looking at this, we're going to turn it off. Again, that switch doesn't per se turn off power. If we're working and putting our fingers in the unit, we need to turn off the main disconnect. We'll put a lockout tag out here. Even if you're standing right next to it, lockout tag out. When if somebody comes over, you walk away, they turn it on or something. Anytime you're putting your fingers in, lockout tag out. I won't touch anything over here. There's 4 clips that hold the cover on. The model and serial number is on the top of the unit. It's etched in. So these are belt driven. We have the 2 grease bearing ports. I handed one of the gentlemen information on the type of grease that we're using. This one right here is called Lubricate 1200-2, okay? That's the factory grease that Cook uses. So for me, it was easier just to get this grease, so I don't have to worry about purging the bearings. You can purge the bearing to change out the grease, but it's messy, and I just use the grease they told us to use, okay? But I provide you guys that information. I believe it's Motion Industries that is the closest rep to this area. I believe there's a couple other, but they were the easiest ones that I was able to get the grease through. Okay. So we'll want to grease the bearings. These fans aren't going to be running all the time. So I would say we'd want to use probably quarterly grease the bearings with no more than like a couple squirts. But obviously, it's going to depend on the grease gun you guys use. Some grease guns distribute more grease than others, okay?
And usually this is contracted out.
Okay.
And
just make sure you pass on the information to them of the grease that the factory provided and that we continue to use.
you can't trust the guys to do that.
But again, that's why I'm providing you the information. You can pass it on. Whoever down the road decides to do with that, it's, you know, as long as I can provide you with the information, you know.
Yeah, I know.
Everyone can do
I
their own
understand, but the reality is, when the service guy comes here, he's got a grease gun, it's full, he's not going to change cartridges in the middle of the job.
Yeah, I know. I get it. As long as
Well,
I'm
to me,
letting you guys know.
The best way to do it is have a grease gun on each side.
Yep.
And just leave it there. Have the guy come every 3 months.
I just want you to know that I'm using the same grease that Cook provided from their bearings from the factory. We have that information and we can go from there.
So now this grease is specified by the bearing manufacturer?
By the fan manufacturer, the exhaust fan
okay.
manufacturer.
Okay. All right.
Okay. We have belt. It is a belt-driven unit. We need to check set screws. We have the motor set screw, and then there's going to be a shift set screw at the other side. And you have a shaft set screw right here. Quarterly, we're going to want to check those the belts and all the bolts and hardware. Make sure nothing's vibrated itself loose. When you're doing the greasing, they should be checking all the bolts and hardware to make sure nothing's come loose. Typical mushroom blast fan. This is a grease accepting fan, so there's a grease box over here we need to inspect too. Okay, just watch the levels in there. It's acceptable to be, you know, it can collect a little bit of water too, so we just got to inspect that. I would say monthly, make sure that thing's not over, that it doesn't need to be cleaned out, and we'll want to follow the proper procedures in O&M for cleaning that, or the health and maintenance manual that deals with cleaning grease. I would assume that's a third party as well, right? Or do you guys clean these out? Okay. So the same thing then. So just make sure we get that, something like that set up for this rooftop too. These are grease fans right here. The majority of the fans up here are grease fans. It'll be EF1D is grease rated, 2D is grease rated, 4D is grease rated, 5D is grease rated, 6D, 7D, and that's it. The other ones are like restroom fans. Most of the fans up here are for kitchen hoods. Okay? And of course the hood itself has grease traps down there as well. So hopefully that's doing its job and the grease is making its way up here, but it's possible we can. Okay? Any questions on this? Do you guys know how to check belt alignment? Just real quick, it is an adjustable shiv. Anytime you have adjustable shiv, you need to compare the driven end, both sides, to each side of the drive end, because as you open the pulley, it's going to slide down, and you want to split the difference of the offset. If you just use the flat edge right here, if you have this thing super opened up, the alignment's going to go out, okay? Keep that in mind when you're doing the alignment and checking belt tension. The belt you pretty much want as tight as possible without squeaking, okay, on startup. Any questions under here? These fans do have a air cooling port. I believe it's going to be blowing air out this outlet right here, okay, to help kind of keep the motor cool, the motor compartment cool. Kind of important. So EF2D, EF2D through EF8D are going to be very similar in the up-glass belt-driven configuration. Our EF3D down at the other end is going to be the only one that's not 463 phase. It's one of the restrooms. Now that the cover's back on, we want to make sure we latch all four of the latches to keep the cover on. There is an inspection. There's hinges on one side. This inspector unit, you can take the 2 bolts. There's 2 bolts right here. Undo those, and this thing will fold up to do wheel cleaning. To check the wheel, do wheel cleaning. Okay. No backdraft damper on this unit. It's a grease fan. You can't have any type of device like that would catch the grease on top. Okay. We'll move on up to this fan right here. This is EF1D. This is also a belt-driven unit. This fan serves the production kitchen. So that big kitchen area in the back where the really long hood was, that's going to be this guy right here. It's also rated for grease. The grease box is underneath the fan right here. There's a door. We talked yesterday, it's very critical. Make sure that this VFD stays in auto. If it's not in auto mode, it will not turn on. Okay? And this is controlled through the ANSYS system as well. Yeah. See, it's important when you're done with the unit. I almost forgot to turn on the power, okay? Turn on the switch, take our lockout, turn on power. The switch for us right now, we'll just leave it in auto mode. Auto, remember, doesn't really do anything. It's wired straight into the contactor, okay? In case somebody comes here and turns the switch off, the fan can still run. That's why I chose it. That's why it was wired in straight to the contactor. For us, we'll just leave it in auto mode, okay? If the unit doesn't run either, there is a overload button right here. Most of the starters were electronic. No, these, I think up on this roof, all the overload assemblies are mechanical, okay, versus an electronic. But that's provided by the electrician. So this is a centrifugal utility fan. It's belt driven. This is an access port to look at the belts. Again, anytime you would touch the belts or do any type of belt tensioning, you'd want to turn off the unit, turn off, lock out, tag out, power to the unit, okay? So this is inspection doors for the motor and the belts. There's dual belts on this unit right here. Adjusting the tension of the belts are going to be this plate right here. This unit does have greasable bearings too. All these screws around the top, there's 3 on the top and all the ones on the side right here. These can just be loosened. It's going to take 2 people to get this cover off, okay? The cover will slide off and then come towards me, okay? 2 greasable bearings at the top of this. Same grease, same manufacturer, okay? This is an inspection fork for the wheel itself. Like annually, you'll want to check the tightness of the wheel. When you're cleaning it, make sure all the set screws are still tight. This is the inspection door into the wheel itself, the set screws on that. Any questions on these 2 fans? Centrifugal utility fan. Feeds the production kitchen. We're still going, yeah? Guys, yesterday, we had surf pump training. My covers were coming in, so here's covers for the pumps. We need to make sure the pumps stay covered, okay? They just lift off to the top, okay? To keep the moisture off of the pumps. There's a standoff bracket here, so it's not sitting right on top of the heatsink, okay? The aquastats have covers too. Keep the covers on all of the devices, okay? Keep moisture off of them. The 2 pumps over here have covers now as well. So there's 7 pump covers and 3 aquastat covers, and then the big aquastat cover box on the side of the tank. Okay, make sure that cover stays on that waterproof enclosure too for the aquastats on the tank. Okay, we'll move on down the road. There's 1 more exhaust fan here, and we'll go to the other roof, and then we'll go inside the building. The covers on these 2 pumps right here. Okay? Make sure we use those waterproof covers. Guys, I forgot when we were at this air handler, we're walking by the condensate trap here. In our submittal data that was provided from us from train manufacturer, they give us the dimensions, minimum dimensions of the trap, okay? So if you ever have to modify this trap, make sure you build it back to the same dimensions or follow the manufacturer's trap height dimensions. They give you the differences between the outlet and the outlet here. It just has to be minimum, right? We can go longer so we can use this curve. We just have to meet those minimum distances from the bottom of this pipe to the bottom of that pipe too, okay? That information isn't in the submittal information. It tells you the height to build all the traps, okay? And then lastly up here, we have EF3D. So this is the only different style, this is one of the two different style units that's non-breach rated. It's a 120 volt ECM powered motor. There's no moving parts up in here unless you stuck your finger down there. It would be good practice to turn off power before you open the cover. Don't stick your hands down there. All of the grease fans do not have screens on the outlet of the fan, okay? Be very careful. This one is not a grease rated fan, so there is a screen around the blower wheel. All the other mushroom fans do not have screens, so do not reach down inside the fan with it running, okay? Don't adjust the speed dial. It was set for the balance of the building, okay? The display will give you RPMs. This is sucking air out. So since we have the dedicated 100% outside air units, the fans, if they're running, will exhaust pressure out of the spaces. Or in the middle of the roof, there's huge pressure release louvers, okay? Trying to think, I don't think there's any on the sides, they're all in the middle. But there's big louvers that will relieve any pressure if the fan system's on, okay? So you shouldn't feel the pressure ever coming out the front doors. If you felt any pressure, air pressure coming out the front doors, it could possibly be that some of those louvers are plugged up, okay? Yeah, they're in the middle, so you'd have to go out down to the floor instead of an extension ladder to get up onto that middle part of the roof. There's no doors or anything to get from these parapet walls to the middle part of the roof. So exhaust fan 3D is going to be like restrooms, lockers, and a janitor closet downstairs. We'll have to check the actual drawings and figure out the actual chase out, but it's going to be restrooms, locker rooms, and janitor. I believe that's going to be in the kitchen area. There's like a locker room, restroom area in the kitchen specifically. Okay? Disconnect switch right here for the fan. 120 volts. Motor's thermally protected. It doesn't need a starter. I do believe it is being controlled through BMS though. Okay? I think it's 3D and 8D are the two fans being controlled by the controls contractor. Everything else is controlled off the Ansel system. Okay, we'll go down to the other side of the roof. Hi guys, Mike with Dale Reed, Building D roof. We're looking at the exhaust fans. We're gonna look at the air handler, and that's the rest of the stuff up on the roof. And then we get inside the building. It's hot up here. We have exhaust fan 5D. It's just like the mushroom fans that we saw on the other side. 5D is gonna feed the grill. Same starter, same controls, keep it in auto, but auto and off. Doesn't really matter. It's still gonna come on through the Ansel system. Belt driven, greasable bearings, okay? EF4D, same thing. 4D is the pizza oven, okay? Greasable bearings, belt driven, okay? Same thing with the starter right here.
As far as maintenance, where the same maintenance like other things.
Same maintenance for the fan that we talked about over there.
Same requirement, right?
Yep, check belts quarterly, minimal.
Oil.
The grease, that same grease that I showed you guys. We have grease traps on the side of these. All the fans are gonna have it except 3D and 8D. All the fans are gonna have these grease boxes, okay? They're all grease rated fans. We have the inspection hatches on these too, okay? You'll do that inspection, I would say too, whenever you're checking those grease boxes. Clean and dispose of properly.
This one was this room.
Dishwashing exhaust fan, exactly. This is the starter for that unit. Same thing again. Switch will be an auto, off, doesn't matter. The Ansel system's turning it on and off. Okay? Some of these have push buttons downstairs though. So the electrician knows where those locations are. So there'll either be a push button, and if somebody forgets to turn on the push button, there's still a temperature switch that can turn on the fan as well. Okay? Okay, that's these fans. This is EF8D.
This one was the bathroom.
Yep. This is the unisex restroom fan. Okay. It's just 120 volt disconnect switch right here. Also being controlled through BMS. So if it's not running and the switch is on, we'd have to go back down to that panel. Okay. Now we get into the air handling unit. These are the moisture limiter filters that I was talking about.
Honeycomb.
So this is the other half of the dining area.
This is the other half of the dining. Yep.
Right from
Yep. And then this air handler is set up the same. We have the outside air filters. We have the canisters for the outside air. There's the 6 I think this one might have 8. There's still the canisters. That's where the flow stations are. Then we have our filters. We have the MERV 8s, then the MERV 13s. They can be cartridge or box as long as they're a MERV 8 and a MERV 13. Then we have our, over there we didn't talk about the piping, but we mentioned it in an earlier video on the piping. We have hot water and chilled water. We got hot water here and then chilled water here. Remember, we have balance valves to keep the flow going through the units equally. We shouldn't need to turn these off. There's no shutoff valve on the supply right here. So if we're isolating the unit, we'll just do it at the main shutoff valves that are right back behind us. If you do work, use the vents that are up at the top of the piping to vent out any air. Same is true on the chilled water. Strainer on the supply, control valve on the return. Same compartments all the way through. This will be the inlet, the door to the inlet of the fan. This door right here is for the electrical VFD compartment. Remember, again, when you're ordering replacement motors, use the part number listed here on the panel. The motors are special motors designed specifically for train air handling units. Okay, so even if you find, you have to be careful using there's like a product ID and then the different numbers that are on the motor itself. If you're in question about that, you can Google Train's documentation on the specific unit and it'll tell you what part number to use. The best thing to do is use the part number listed on the side of the unit.
Same thing, it has front or two?
I'm sorry?
It has front like the other, yeah, right?
Yeah, the inside of the panel is exactly the same.
What are the same maintenance like the other, yeah, too?
With opening this door?
Maintenance,
Yeah, the same maintenance? Yeah. The VFDs, there's 2 VFDs in this one. I believe the max hertz on these 2 VFDs are 76 instead of 73. Close, but not exactly the same. That's all in the submittal information. We have a light switch up here and a GFCI outlet. And then the controller, the Sunbelt's controller is in this panel. And then we got our supply air doors here. Remember, this is the door. Be very careful opening this door and getting inside the unit. This is the down blast plenum is in this door. This door right here, you can get into the same part of the unit. Okay. So that'll be your access into the two motors. The motors are in this compartment right here.
That's the back end of the motors?
Yep, and the fan wheel itself. So obviously before you go in this unit, make sure you lock and tag out the unit and it's off and not running when you go in it. But do be careful when you go in, because just to the right there is the down drop plenum.
So you have to turn this off before you run.
Yeah, you'd want to turn off the unit and lock and tag it out, because if you just turn it off, somehow if it somehow turns on. The disconnect, you can just use that disconnect on the outside of the unit. Guys, this is the master disconnect. If you turn this off, it will turn off power to the entire unit. Okay? Make sure the latch comes all the way down. We already talked about this door. Same's true with the condensate trap. The dimensions are on the submittals. We've built it to the submittal data for the manufacturer's recommendations. We have one more exhaust fan over here. Another centrifugal utility fan. This is 6V. So this will be global. Okay? The global station is 6V. Again, it has a starter. This one potentially could have one of those push buttons I was talking about, or they're using the device downstairs. We're in auto mode and the fan is running. So if you have to work on it, even in the off mode, it won't turn it off, okay? Because it's being controlled through the ANSYS system or that push button. So you need to turn off the disconnect switch to work on the unit, okay? Any questions on the fans or the air handlers up here? Filter changes is gonna be the most important thing for the air handlers, and making sure the drives are in auto. And then cleaning out the unit as necessary if there's dirt or debris in it. Clean out the condensate drains, condensate traps. Condensate traps and drains you'd probably want to inspect quarterly again. Make sure there's nothing developing in any of the drain pans. Okay. Inside, we'll do fan coils. There's two really small ones. All right, guys. Mike again, A.O. Reed. We've covered all the equipment, the exhaust fans, and the air handlers up on the roof. We've come down into Building D. We're in the main electric room. It's at, I'd call it the southwest corner of the building. We're going to talk about the fan coil. Currently in Building D, there are 3 fan coils. 2 fan coils are in the IDF rooms. Those have been turned over to the university. I don't have keys to those 2 rooms. We'll show you guys the locations of the doors to those, and the equipment is going to be the same as the one above us in the electric room. Okay. So this is fan coil 3D up here. We got the discharge side over here. We have a secondary drain pan coming through the unit. We got an access door on this side of the unit, and we have an access door on the other side of the unit. This side of the unit that has the controller is going to be the side you'll want to use the access door on. It has your model serial number. But the blower, I guess it doesn't matter what door you open it.
Just not.
So these are direct drive ECM motors. Okay. These the fan coils over here for you guys are all 0 to 10 volt speed signal control. But the control guys are just taking 3 speeds. So we didn't have to worry about the rooms. I think it's down over that way. We'll look at it a sec. There's 3 speeds. So like this one, 3 volts is high speed, 2 volts is medium speed, and 1 volt is low speed. Yeah. So highest voltage is the highest speed. That gives us to the design CFM that the engineer wants. Okay. This is the starter assembly for it. This black knob right here is the disconnect switch. That's the unit's disconnect switch. The Sparky's provided an external disconnect switch right here too. So if you needed to work on something in the unit, shut this one off. But to open the door, you're still going to need to pull this out. And you could open the door with that latch right there. To get the unit to work, you'll need to put that black piece back in its female counterpart, okay? It's like a residential disconnect switch on an air conditioning unit right here, okay? And then that way the unit will be powered. Once you put that back in, you'll have to flip the switch on, and you'll have power through the unit to do your voltage testing. Anytime you're doing live electrical work, make sure you follow Cal Poly Pomona's proper arc flash procedure and voltage checking procedures, okay? So these right here, there's a terminal strip inside. There's 4 terminals. The middle 2 terminals are your speed signal. Make sure you look at the wiring diagram and follow which one's the neutral versus the actual 0 to 10 volt signal. And then the ones on the outside are going to be your 24 volts that power any external devices and also power the motor itself. Okay. So that speed motor does take 24 volts to power it up, and then it also gets a 0 to 10 volt signal to run. It also is using 277 volts to spin the motor.
Oh, 277?
Yeah, so these fan coils are 277 volts, single phase. Okay.
Single phase.
I mean, single phase, 277 is only single phase 480.
Yeah.
Okay? Well, it's one leg of 480.
It fucks you up.
Yeah, it won't feel good. Okay? So these are 277 volt fan coils. Remember the sheet I handed out to you guys? I said there is a list of all the fan coils with condensate pumps.
Yes.
And building D, your guys' building, this is the only unit that has a condensate pump. Okay? So this guy at the bottom is the transformer. We're going 277 to 120 volts. That is run over to, dang it, they covered it with the pan. You see this trap right here? So we have a condensate trap.
Oh, that's right inside.
Okay.
Oh.
This black 90 is going to run you into the float assembly.
And the condensate pan.
And you can see this little piece of tubing I'm shooting with the laser.
I see that.
Make sure that stays on, okay? That will, if the pump stops pumping, it'll allow water to build up in the float reservoir and make the alarm switch. Okay?
Okay.
Without that, it'll spill out of the pan and it'll make a mess. Okay?
I noticed that you got a drip pan for the roof drain.
Yeah.
But yeah, you got the outlet on top of the panel.
They just hung this. We'll make sure we get that rerouted 90 to the wall and then run down to the floor.
What are the alarm on
Yeah, it'll just be a tattletale. For our contract, it'll just go over to the wall and down to the wall. Eventually, if you guys want to add some type of a switch in there, you can, but you need to plug that open. If you have a switch, unless you have an electronic moisture sensing switch, but if it's like a float style switch, obviously that won't work. All the other units have float style condensate switches, okay? So that would have to have a plug drain versus a like water sensing strip or something like that.
there? All right.
Okay. This one will get piped to the wall as well. So this one is borderline. If a drip happens, the transformer's a little too close, so this one will have a.
Send it outside. You
Yeah,
wanna
it'll
send it
probably
outside?
just be local to this room.
Tray or something.
The tray is right here, so this is a drip tray. So we just need to make sure if it drips out the tattletale here, it doesn't create a splash and create an issue for the transformer. Okay? So those will have, tattletales will be extended out so they don't cause an issue. Filters here in the back. There's a filter door here. And there's a filter door on this side over here. I think I got distracted from my pump. Filter door here, either one will allow you access to pull the filters out the side. Either side will work. There's a filter pull on all the units, like a tab at the bottom. So once you take the door off, you can pull that tab. Both filters will slide at the same time. Just be cognizant, see this piece of metal right here? That's strengthening the inside edges of the filters, so the filters need to fit in that. That's coming out with the filters. Put that back in when you guys are done, okay? Back to our pump, we had the float here. There's tubing that runs over here and up to the pump assembly. So this is the pump assembly. It's mounted up here because the cord now fits into the electrical compartment, okay? This pump will pump the water up and then into this drain, okay? This is a anti-siphon / air bleed. So as the unit pumps and the water comes back down, air bubbles will enter here, allowing the water to drain out the drain. Make sure that stays there. Maintenance on this is mostly the filters. I'd say annually you want to look at the blower wheel. Make sure it's not getting dirty. Clean as needed. I'm hoping you're not cleaning the blower wheel every year. We'd want to get back into a filter program. chilled water only going into this fan coil. You got supply and return here. We have a strainer down here, control valve up here. The valve is open. The pointer is in line with the pipe right now. If you do have to take the actuator off, make sure you pay attention to the valve itself. You can install these backwards to where that would be closed, and if it was facing down, it would be open. This specific unit right here is a three-way valve. So on the valve itself, there's going to be little dashes. You have a dash, dash, and a dash down here. Wherever the straight lines across are the flow, okay? So if you turned it, it would not be flowing if you lined it up with this one. The copper pipes right here, this is going to be your DP control for the chilled water pumps for building B. So this differential pressure is what's speeding up and slowing down the pumps we did training on the other day. Yep. So since this valve is 100% open, the bypass is closed, all the water is going through the coil. If it was halfway, you'd get half and half.
So what are you saying, it's the temperature or the pressure on that controller?
On the controller, it's pressure. This guy right here is differential pressure, so it's looking at one pipe pressure versus the other pipe pressure. So what they did here, what the balance guys did here is they verify all the units are flowing chilled water. We have 3 fan coils, right? 2 air handlers, okay? So all of those units are open, the valve is open, and they get the total flow. Then they see what the differential pressure is here at that condition. They write that down, they put that in the computer. So then as the valve starts closing, it will build up pressure, it'll slow the pump down, okay?
So that's the signal for the pump.
Yes, through the BMS.
The pump's up on the roof.
The pumps up on the roof, the chilled water pumps.
Sure. Yeah.
The heating DP is up on the roof, right near the piping that comes down the building. This is chilled water DP.
Okay.
And if the differential pressure is low enough here, it won't even run the pump. If we're in range,
Yeah.
or if it's too high, excuse me, if the pump's, as it goes up, it'll slow the pump down. So if it stays up and it doesn't need to run a pump, it won't run the pump.
All right. This is part of the end of the run.
This is the end of the run.
All right.
The CERT pumps were way on the other side of the roof. We're even farther, remember the first parapet where the water heaters are? We're even further out beyond that of the building. Does that make sense? We're past the main kitchen right now.
I know.
The main water shutoff valves are in a room right next to us this way. Domestic water shutoff. Again, this pump is powered off of the transformer sticking out the bottom of the unit. Okay. Any questions on this fan coil?
So this fan for this one.
Only for this room.
What about the
Electrical gear.
This is for the whole
Their
building.
training is next week.
This is for the whole building. That panel's for the whole
That training will be next week.
electrical panel?
Okay, let's go in the building. I want to show you the locations of the 2 fan coils in the telecom rooms. I don't have keys right now. It's already turned over to the campus, but at least you know what room it is. It looks exactly like this. It just doesn't have a pump. All the
Okay.
drains are gravity drains. Okay? Same maintenance. The only difference there, we don't have a 3-way valve. Since this is the farthest run on chilled water, this is the only 3-way.
Oh shit, we're not supposed to have 3-way valves either.
This is a 3-way.
Okay, of course. What the back?
Because we get charged by the BTUs. So we're bypassing it, we're picking up something.
Yes.
So-
Yes, potentially. But
Because we have a building, all our buildings are tied to the same system. We all have 2-way valves. That way when it opens, it feeds, when it closes, there's no flow, there's no charge for BTUs.
yeah, I'd heard that. I don't know where we stand. The design for this building was to have 3-ways. Same with building A and B.
That's
I mean, potentially it's always something that could get removed.
Mhm.
But as far as I know now, that it's staying how it is.
Yeah. Shit. All right.
And yeah, there's no way to
See,
isolate.
well, actually, we don't pay it. He
the
pays
campus.
it.
Yes, I understand.
Don't pay nothing.
All right, guys, let's move on to those other ones. All right, guys, we're doing training today. We have air handlers. We've gone over air handlers, exhaust fans. We're on fan coils. We just covered the main electric room fan coil. We're moving on to the second fan coil. It's gonna be located in the men's restroom 117. If we go inside this door, we got IDF room 2, 117A. These rooms have already been turned over. We don't have access to inside the room. This unit is hanging in the ceiling. It's identical, just a different size of the one in the electric room, okay? Same filters, same chilled water. They said the only thing was different, this doesn't have a three-way valve here, okay? Same schedule for maintenance on the filters. Again, this condensate is gravity draining to underneath the sink over here. This black pipe right here is going to be your drain. Okay?
Mm-hmm. My first screen runs like this, the unit. It comes with a white,
White tailpiece drain.
in the big bathrooms.
Okay.
Yeah.
Okay. We have exhaust fan EF112A. 24/7, no controls, disconnect switch up on the wall. Okay? It just discharges air to the roof. EF112A. This was added in an RFI or a change. Change exhaust fan, it's called 112A. It just the discharge just goes straight up to the roof. I think this is the roof. This might be just beyond the parapet wall.
Okay. And what is this for?
Just this area right
The
here.
vent for this room?
Yep. It's not going to show up on the schedule I had. It was a change. There was a change at some point.
Something in here?
Sure. There's only 2 exhaust fans that are in the building. That's one of them, and I'll show you the other one. So down here at this floor drain, there's this pipe right here. It's going to be the condensate drain outlet to the other IDF fan coil. Okay?
The other fan coil?
The other IDF room fan coil, that condensate is gravity fed to right here.
Expect that.
Yes. If that's the outlet for it, we're going to go, I'll show you the room.
And that's probably tied into those machines too.
Those machines, no, those machines will have their own dedicated drain going in there. That's its own dedicated drain from the fan coil. Okay, IDF room 1. Room 110B. This fan coil is the same, is similar to the ones in the electric room and the other IDF room. It's just above ceiling tiles. Okay. This one will have a tattletale in the IDF room below the ceiling grid by the time we're done. Okay. Okay. T-stat is on the wall in there, controlled by BMS. That's the 3 fan coils. So this is the drain that I just showed you right outside, coming from this unit right here.
All right.
Okay. Just got one more exhaust fan to show you guys, and we'll be done unless there's any other questions. Okay, let's go do the last exhaust fan. There's just an IDF room back there. Yep. Peace plug? You put a peace plug in? Oh, I get it mixed up. Where's this last one? I think it's in here, sorry. EF 102A, and we are inside room
102A.
the prep room. 102A has exhaust fan 102A in it. Okay, just a little fart fan. All of steam or moisture, ventilation for that.
Another fucking extra. God
Okay.
Okay, no, that's
Two exhaust fans in the building, 102 and 112.
yeah.
All the other ones are up on the roof.
Okay.
Three fan coils, 2 in IDF rooms, 1 in an electric room. 2 air handlers up on the roof.
Right. What's it called? Lobby cup.
Any other questions on any of the equipment that's in building D? On the roof, water heater stuff, plumbing stuff, boilers, heating hot water, chilled water. You guys all know chilled water comes from the central plant, right? We're making heating hot water here. You're making domestic hot water here. 2 separate systems here. Since we do have air handlers here, do you guys know when you have an air handler system, right? You blow out a certain temperature air and it gets fed to different zones through VAVs. Okay, so there's VAVs scattered throughout the building with reheat coils. Okay, the drawings will have all the locations of those. Sunbelt is controlling the VAVs and the hot water valve and the zoning, the temperature zoning.
Are they located usually where the blueprints say?
The VAV itself?
Yeah.
Definitely use the AORE drawings, but yeah, they should be pretty close to the AORE drawing, or they're right where the AORE drawing shows it.
Okay. Right.
If you look at the contract drawings, it will be close to that.
All right. Okay.
But if you use the AORE drawing, that's exactly where it's set. The AORE drawing is the as-built. Yeah,
Makes it easier to find that.
that's true.
All right. Need tall ladders, dude.
Yep. There is one up here.
We're gonna need a little mark lift, a 1-man mark lift. There's a VAV box in here up there.
Yep.
Point that out.
How are we gonna get in there?
You can. Extension ladder with padding on the top of the feet. I know. It can be done though.
I know.
I said the same thing.
Okay. All right.
All right, guys.
So this is gonna be done by the 9th, isn't it? We get the 9th.
5th?
The 5th? Okay, all right. All right. Can't wait.
Once you get in and get used to it, it won't be that bad.
I won't be in here, not for a while.
Okay.
Any other questions?
I'll be everywhere, but if everything's there, everything should work.
Yeah, but some of the equipment will still definitely need maintenance, right? We need to grease bearings, check belts, all that kind of stuff.
Filters.
Filters, yep.
And it's only me and one. All those apartments over there and all these other buildings, it's just me and one. So that'll work.
It is.
We're doing the HVAC.
All right, guys. Any other questions?
No?
Okay. Thank you very